So there you have it. This is the last piece of Maxwell's equations. It's the last piece of the foundations of 802. It's the last part of the structure that we've been building since the beginning of 802. Before we move on and look at the structure as a whole, as with any of these equations that we've come to in the recent parts of 802, we have to make sure we get our signs right. So when you do the integral of b dot ds around some contour C, you have to ask which way around do you do the integration. And when you do those surface integrals on the right-hand side, either the integral of j or the integral of dE dt, you have to ask, when you do the surface integral, do you make your normal vector point out at you or point from you towards me? So it seems like there's 4 arbitrary possibilities, and the important thing to realize is that actually you only get to make one choice. Once you've made your one arbitrary choice, there is one arbitrariness, and it doesn't matter which choice you make, but once you make your one choice, everything else follows. So you take your right hand, and you have to first of all decide which way you're going to do your integral around the contour. And if I do my integral around the contour this way, then my thumb is pointing towards me, it's pointing away from you, and that means you have to choose a normal vector n hat which points away from you towards me. On the other hand, if I come over here and if I decide that I'm going to do my integral of b dot ds this way around the contour, then using my right hand, my thumb is now pointing at you. So this time, if we make the choice to do our integral b dot ds in this direction, then that on the left-hand side of the equation, then on the right-hand side of the equation where these n hats occur, we have to pick our n hat going towards you, from me towards you. Either of these works fine. You just have to remember, once you have made your choice for which way you're going to do the contour integral, the integral b dot ds, are you going to do it around this way, or are you going to do it around that way? Once you've made that choice, you no longer have any freedom of choice for which way your n hat points. Your n hat is then fixed by the right-hand rule. So this is very, very similar to the discussion we had with Faraday's law. And this is the last piece that you need in order to understand and apply this last fourth Maxwell equation, fourth of Maxwell's equations, the one that Maxwell himself contributed the most to understanding. So what we're going to do next, over the remainder of 802 really, is we're going to see what these equations describe. But before we do that, this is an appropriate time to say, ta-da! We have spent the entire 802 up to now building up these equations, building up our understanding of these equations, and now here they all are. These are Maxwell's equations, and these you can take to the bank. Okay? These have been good since the 1860s. They will be good for 1,000 years. These describe electric and magnetic fields. Here they are. This is what we spent all this time building up, and we've already seen in many ways how they describe nature and how they describe all kinds of the basis for all kinds of technology. We're not done with that yet. And in fact, there's a very, very important realization that was Maxwell's second great discovery, and that comes directly from these equations once you have them in full.